I come to question 11b, part 1 of the National 5 2015 physics question paper. This is really quite a tricky question to get right. There's lots of areas where you could make mistakes. Probably one of the most common challenges is drawing the scale correctly on the graph. And in fact, even choosing the right graph to draw. Now we have two sets of data which are increasing at a continuous rate. There's and both of those data sets would imply that we should use a line graph, or a scatter graph as it's known. So let's read the question. A student drops a marble from different heights and measures the diagram of each crater that is formed. The table shows the student's results. So you can see the height increases from 0.05 all the way to 0.45 meters, and as that increases, the diameter of the crater also increases, but seems to start to level off here as the height increases. So we're going to try and draw this graph just now. It's going to be quite tricky, but we will give it our best shot. So we can see that the height values are increasing from 0.05 to 0.45. So that's the thing that we've control over. So that's what's going to go along the bottom. So let's add that in first. So along the bottom, we'll get our pen and we'll put in the values. So we've got 0 here. 0.05 was the first one. 0.10, 0.1, oops, 0.15, 0.20, 0.25, 0.30, 0.35, 0.40, 0.45. Now bear in mind that these values have to go up in a linear scale. If any of the scales are drawn incorrectly, so you say you do 0, 0.05, 0.10, and then 0.20 in the next section of 5 boxes there, that would be a non-linear scale, and so you wouldn't get any marks at all in the graph. So we'll just add in our unit here. What was this again? This is the height in mass, so we'll go back down again and we'll align that up. So that's height in mass. So no, not height in mass, height in meters, I mean. In meters. And then up the side we had, what was it again? Diameter. And that ranges from 0.03 to 0.076, so 0.08 I suppose. So we'll go back down and we'll try and enter that. So that's the graph light up again. So up the side we have diameter, diameter, and that's also in meters. We'll get the units correct. So I'll start at 0. Nope, I've forgotten. 0.03. So let's line that up again. So this would be 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07. And I think we had to go up as far as 0.08 actually. And 0. Oops, a bit high there. 0.08. So that's our scale drawn now. It's a wee bit rough, but you can see it quite clearly. And what we're going to do is we're going to just check the data values that we've got. So the first one is 0.05 is 0.03. So go back down, we'll fit everything in where it was, because we want to get that right. 0.05 is 0.03. So that means that our first data point, and we might just do a different color just because we can, and we'll choose red. 0.05 is 0.03, so that's right here. And let's see if I can get it right on the mark. There we go. And the next one is 0.044 and then 0.053. 0.044 and then 0.053. So 0.044 is here. Make sure I actually got a red pen. And then 0.053 is here. So that's 0.052, 54, 56, and so on. So 53's smack bang in the middle of it. Okay, we're doing well. I've got a couple more. And then 0.074, 0.076, 0.076. Now there's one thing to notice here, very important, that there's a jump from 0.15 to 0.35. So you would think that 0.2 and 0.25 and 0.30 will be in there. So there is some data missing. So we need to make sure that we plot that accurately. So the next one is 0.35 and that's got a diameter of 0.074. So the last three are 0.074 and 0.076. Okay, so let's get this right and we'll do it as accurately as we can. So 0.35 was 0.074, so 74 is there. So let's just mark it in, and then 76 is the next two, and here as well. So that's the lines plotted. What do we get for that? We get a mark for drawing the scales correctly, making sure that they're not non-linear. We get a mark for, well, that mark also includes, the height labels and the units as well, diameters and meters and height in meters. And then we get our second mark for plotting in all the points correctly, and these have to be plotted within half a division accuracy. And then the last one is for the best fit line. Now let's see if I can draw a best fit line. Again, I'll choose a different color just because I can. Let's go for green and we'll see if we can draw this line in. So it starts here. You don't need to extend it any further than that, and we go all the way up, and that's not bad, but you can see here that there's it's a wee bit too high, and actually I don't think I'd get the mark for that. So the next thing that I can do is just get rid of it and try that again. So we start here and we go up, and it should be a nice curve. Again, I've got a little bit of a kink, so I will try once more. Unfortunately, if you're doing this, you don't have many chances to get it wrong, unless, of course, if you do it in pencil. So I think that's not bad now, and that would probably be worth the 3 marks. Maybe a generous marker might think I've made a bit of a mistake there. It might be better to be drawn flat. So what I'll do is I'll just rub out this little section here, and I'll try and draw it in flat if I can. That's better. Okay, a really hard question to get perfectly right. That's partly because getting the scale right is difficult, and also sometimes you can put these numbers in the wrong place, these data points in the wrong place. But all in all, it's a good question.